Questions? Yep.
So in anthropology, Robin Dunbar has argued that traditional human hunter-gatherer societies tend to grow until about 150 and then fission. Have you looked at the sort of, could you model the cost of forming connections and when groups might split?
I certainly haven't done it. It's a very interesting thing to look at from a theoretical standpoint. There's a way I would address it is write down a reasonable model based on the actual costs involved, underlying stochastic model, and look at what the parameters need to be to see these actual splits, the characteristics of the model involved, and then see whether those parameters make intuitive sense, whether they seem realistic or not. But this would give away, I think the latent space model would be better appropriate for it to have those forms. The other thing I haven't mentioned here is a bunch of models which you can do based on the essentially a utility function approach. When you think about whether you have ties or not, you look at the utility of that tie, and you have a cost associated with it as well, so cost and a reward to it. So you'd set up an individual utility-based function, and that would be a very useful way to address this hypothesis. You could just see how the costs and the benefits change with distance. No, but I haven't looked at it, and I haven't seen what I'd call a definitive analysis of it. I think what you'd probably find is that in some cases it's reasonable, but in most cases it's probably not. It's a good, yeah, anyway. So I'm actually just going to stop here, and if there are other questions or either more broader aspects, I'm more than happy to address them. Yep.
The same line of the previous question, if you then go to the opposite direction to one dimension, so can you do a good job there?
Yeah, I actually think you can do it in one dimension. We've done it, and it sort of makes sense. What I find interesting is that in one dimension we can also, I haven't made it explicit here, you could use it as a one-dimensional with a hierarchy involved. So instead of thinking about it as a line, you think about it as vertically, if you will, where if you're higher in the point, you're more likely to have in-ties to you than if you're lower in the point. So people with lower status will nominate as friends people who are higher status, but much less so vice versa. So your one dimension would be a directional dimension and would give you a nice linear hierarchical representation. And that can be done here. It's a very useful thing to actually do. It's very useful. They can also be molded with more sophisticated hierarchical specifications in two dimensions, taking into account the directionality of the space. I'll just mention, just to expand on that a little more, it seems natural to have Euclidean metrics in terms of distance here because our eyes are so good at looking at figures of this kind, although there's some excellent work done by Peter Hoff who looks at projection type measures, where instead of looking at Euclidean measures, the measure of distance is or not distance, but the measure is a projection type measure, which is extremely interesting in terms of the structural forms. Another work done by Tom Snyders and Michael Swenberg was at so-called ultrametrics than these, and they tend to be very good at measuring higher hierarchical forms. So there's a lot you can do with this basic form just by changing changing the specification aspects of what makes the social structure simple. Yep.
So the latent space is it possible to extract so specify, say you want two dimensions and you extract what the dimensions are from the data? Is that how you do it, or okay? So it's not that you're not deciding what the dimensions are before and then fitting the model to that. I'm thinking about something like factor analysis, where you extract the dimensions from the data. And I didn't quite get the technical aspects of how you're doing this, which one it is.
That's a very good question. In the version which we've published here, we actually fix the dimension and go through it and then use the various model selection components to do it. But the methods, this is work done in 2006. Since then, there are methods that can also choose the dimension in the various forms involved. But it is similar to a factor analytic in its conceptual form. In fact, it's effectively a form of a model-based form of multidimensional scaling. This is what we've done here for relational data. But that issue is always going to be there. If you add additional dimensions to it, you will get additional fit, but then the question is it worth it? Now you can look at whether the additional fit is statistically significant or not. That's something that's reasonably well posed. But thinking about it scientifically, the core issue is you'll probably be able to explain a little bit more of the social structure because, as I mentioned earlier, as I emphasised earlier, these are very complex systems, so it's highly unlikely that additional complexity to the model won't find more real social structure to represent. Then it becomes a scientific question: is that additional social structure worthwhile to represent? It's real, but is it worthwhile? And then it comes down to, I think, the interpretation of the lower dimensions involved. And usually I think the simpler representations actually have a lot of scientific value to them, even though you know you're missing out real structure. Because it must be that there's real structure in the social systems beyond these lower dimensions, because social systems are very complex.
So just following up on that,
yeah.
Then so that latter, more multidimensional scaling method, I guess I have two questions. Empirically, when you look at networks, if you do it that post hoc way, do you tend, and say you have two dimensions, do you tend to get a different answer for what the dimension? Do you get different dimensions than if you did it by specifying the dimensions beforehand? And are there sort of, the other question I would have would be, often when you, in psychology, when you do factor analysis, people will put an intuitive description of what the dimensions are, and they'll sort of say, this looks like personality, this dimension looks like introversion, extroversion, and then does that happen in graph analyses where people say this dimension looks like something like intuitive?
It happens. It's exactly the same issues, and the reification's an enormous issue in this area. So from a philosophical, conceptual standpoint, it's exactly the same as factor analysis and these other forms. You have to be very careful of doing it. And we know they're very complex, and describing them in these ways, it's useful to see that structure. There's an advantage of it, but saying that now that I have this decomposition, I'm describing this structure or giving the insight into the structure, that's a way step too far. You would need to have a lot of theory. This is more, I would put it in different terms. I would describe these as descriptive models. If they were descriptive, useful visualizations, they tell you where a lot of the variation in the data is and what's important in terms of the data. But to go that extra step to say that these are sort of driving things, you would definitely need a social theory coming in to say that these are reasonable or not. And there's, of course, great concern about over-interpreting in factor analysis and in these methods too, which everyone must resist. It looks good, it must be real, but we all know that's rarely the case.
Of course, in this situation, wouldn't it be possible to use the emergent structure as a way of deriving additional hypotheses about what's going on, and then going to external data, like data not already in the model, like attributes of the actors, and saying, oh, this looks like there's a social class distinction here, or a gender distinction, and then presumably there's some way of testing the extent to which introducing those elements will I don't know, do you test whether it is, I guess the extent to which it's correlated with the distances, however you measure it.
Yeah, I agree with that. One useful thing to do would be to suggest structures that are there and then go and test to see whether they exist. This is initially used at an exploratory stage, could be used at a confirmatory stage also. Very useful thing to actually do. We have to be a little bit careful, though, I'd add to that, is many of the tests test for presence or absence or not. I think in most systems it will always be present, it will just be of a smaller scale. So it will be just a trade-off. In many circumstances, I'd be very surprised if there's no more social structure than what is described by these lower dimensional models.
A follow-up on that, I guess, two points. One, is one of the statistics that emerges an ordering of the dimensions from strongest to weakest? Say in factor analysis, the most factors is strongest. So is that emerge or no?
No.
Not in this.
No.
So you just have to, decide.
Yeah. That's right. You could fit one dimension, two dimension, and so on, and you can always project the one dimensional down to the two dimensional down to the one dimension. But there's no direct decomposition in that way. I should also just state one of the advantages of these models is they give uncertainty of the positions. They don't give you point positions. They give you distributions, joint distributions over the positions. And I haven't shown it here, but that's extremely useful in interpretation aspects of it. Yep. Question?
So, given the importance of the selection of the number of dimensions, it would seem that at least one way of potentially addressing this, I presume there are techniques for this, is anytime you have longitudinal data, you can select arbitrarily your initial number of dimensions, generate the network, and then on the basis of that, predict what happens when aspects of the network change, and then compare that with the empirical data that you have at point 2. So in your, adolescent school children, for example, they graduate, right?
Yeah.
And the cohorts will change as a function of,
Yeah.
of the presence in the next sample. Or, but I noticed that some of the work was sponsored by DoD. Presumably they're very interested in what happens when you remove central nodes in a network to a social network.
Yep.
Then you can retrospectively go back and see, well, what is the minimum number of dimensions necessary to accurately predict the change in the network that has occurred?
That's exactly right. Yeah, in fact, on both those scores, that's exactly why it's of interest. If you did remove someone, note that the model specification enables the removal of someone and says what would happen in those circumstances. So that's an empirical question. Yeah, so both of those are true. The other thing I just mentioned, it's interesting in these models, it's natural if you had data longitudinally over time, multiple networks, it's natural to think about the position starting and then drifting over time as you go through. So within these models you can fit them either separately at all the time points and look at how they evolve over time, or actually have a direct model for the evolution spaced over time of each of the locations. And both those generalizations are being worked on recently. Question? Yeah.
Can you quantify the quality of a model? Say if you have competing models for the same data.
Yeah.
Can you quantify their agreements with the data in some way, which allows you to select among the models?
Well, interesting. The answer is yes. Most of the inference, I think, in this case is better to do within a Bayesian setting because of that. And then you can use standard, not standard, but reasonable Bayesian-based model selection criteria, Bayes factors, and otherwise. And I think they're useful to do. I myself am much more comfortable with sort of Bayesian model averaging notions, or just looking at them in the various forms, just as separate forms involved, not necessarily making a choice between various classes of models or even dimensions. Again, because I feel that they're in some ways descriptive in the sense that we know that there'll be additional structure we won't get. So if we did a very formal model selection approach, it would say you need a large number of dimensions involved because there's additional structure which we have enough data to statistically identify. But on the other hand, the sequential, as you add the different dimensions, looking at different structure, pulling up the degree of the structure, I think is interesting also. So viewing it less as a model selection and more as a sort of model, a sequential model description, I think is very useful.
When you use Bayesian methods, how do you choose your prior distribution?
Well, I think that's very interesting. So to come back, there's two. You could use priors which in essence are so-called reference priors, which indicate little knowledge about what is going on. Or if you had longitudinal data, you could use the locations at previous steps, which I think is very interesting. Or if you had a reasonably complex social theory, you could use that for using that to specify the prior also. In this case, we've used reference priors, which are reasonably complex but relatively diffuse, and then looked at the impacts of those priors upon the outcomes. But the best way is to do it through either a social theory that would generate how the point should look, which is quite possible in this case, or through a previous experiment, either longitudinal data or previous analysis, but that's an intrinsic attribute of these methods. And it's a downside of them at some level if you struggle to elicit that, but it's also a plus in terms of you incorporate uncertainty through the Bayesian approach throughout, and you don't lose uncertainty, say, choosing a single maximum likelihood estimator or so on. So one thing I've noticed here is that if you compute maximum likelihood estimates of the locations, they're dramatically less interesting than looking at the full posterior distribution of them. The full posteriors give you a much more nuanced and richer view, where this is a case where maximum likelihood is substantially worse than looking at the full Bayesian viewpoint. That's certainly a factor in this as a Bayesian analysis and any Bayesian analysis. Okay, great, thank you.